Hey guys, sorry I couldn't be with you today. But I have done a video of the lesson so that way you'll know what to do on your homework assignments. And before we start, I just want everyone to take a deep breath and breathe out. Now this assignment is going to require some trust because it's going to look very complicated and very scary. But I want you to believe in yourself, believe that I'm not going to give you something that you can't handle. And it's going to look scary for a little bit, but I'm going to show you how to make it a whole lot easier. But I want to make sure everybody knows where this is coming from, so that's why I kind of do the long way first, and then I show you the shorter way. All right, so our lesson today is about operations with complex numbers. So it helps us to define, well, what's a complex number? A complex number is anything can be written in the form a plus bi. So the a and b stand for constants. They're variables. Constants. But that I should look familiar from our last class. I is our imaginary unit, which equals the square root of -1. And this is a complex number. The reason they call it complex is because it has two different parts. It has a real part, basically a part that doesn't have an I in it, doesn't have an imaginary part, because remember, it's imaginary because it can only be exist in our heads. It can't be represented by something in the real world, so it's not a real number. So this is the imaginary part. When we add a real part and an imaginary part together, we can't actually add them because one of them has an I and one of them doesn't. But the way we represent it is by putting the real part first and then the imaginary part, and the whole thing together is called a complex number. So if I was trying to simplify something like the square root of -6 plus 4, the 4 and the root 6, 4 can't be simplified any further. This root of -6, remember, it's like the square root of -1 times the square root of 6. I know the square root of 1 is just I, so I'm going to do 4 plus I root 6. These can't be added together because the I is going to be acting like a variable. So it's not a variable, it's a number, it's an imaginary number. But it's going to act like a variable in that we're going to combine like terms, and 4 doesn't have an I. So you can write it as 4 plus I root 6 because in general we want to put the radical second when we're writing out our numbers, but the B would stand for any number that comes in front. So if you wrote 4 plus root 6i, you would still be correct. You just need to make sure that that radical ends after 6 and you don't include the I. So be careful. All right. So let's move on to some examples where we need this information about complex numbers. So when we're adding and subtracting complex numbers, that means they're complex numbers, so they have an imaginary part and a real part. And we're going to be adding them or subtracting them. And what trips people up usually on this unit is that they see parentheses and they think, oh my gosh, I have to multiply. I remember this foiling, been doing this since I was in middle school. But I want you to notice they're parentheses, but what's in between the parentheses? Should see a subtraction sign. So that means we're not going to multiply, we're going to subtract. The reason they're using parentheses in here is just to differentiate. This is our first term, and we're subtracting our second term. So that means we can drop the parentheses out front, and we need to make sure we distribute that negative to every term in the parentheses. And luckily there's only one, so we just do minus 14i. Now, like I said before, the I is gonna act like a variable. It's not a variable, it's a number, but we only want to combine like terms. So -14 is our only real part, and +3 and -14i are our imaginary parts. So we're going to combine the like terms. So -14 stays the same. 3i minus 14i is going to be plus -9i. You could also say -14 minus 9i. But notice that the answer, it has to be in that a plus bi form. So basically it has to be a complex number. So I know this looks scary because it's got this I, but I want you to treat it like if it were a variable, a like term. It's not going to change a whole lot from what you've been doing. Alright, so let's try doing a binomial plus a binomial. And once again, we've got those parentheses, but don't be fooled. There's a plus sign in between. So we can drop the parentheses as long as we're adding both of the terms in the second parentheses. So negative 55 plus 94i plus 13 and plus a negative 12i. Once again, we've got real parts and we've got imaginary parts. So we're going to combine the real parts and combine the imaginary parts. Negative 55 plus 13 is negative 42. 94i minus 12i is 82i. And that's as simple as it gets. Remember, this negative 42 is real and 82i is imaginary. We can't combine them together. So this is our answer. This is our complex number. Now, when Miss Heilman was growing up a million years ago when dinosaurs roamed the earth, she had to memorize all of this and do this all by hand because she didn't have fancy calculators like you did. So I want to show you how this is a whole lot easier to do by using Wolfram Alpha. And the reason we're using Wolfram Alpha for this as opposed to Desmos is because Desmos doesn't have the capability yet. And if you were actually in class, so if we didn't have COVID, the calculators you would be using would have this capability of doing operations with imaginary numbers. So I want to make sure that you get used to using all the resources you have. And I want you to get comfortable thinking, okay, I mean, I could do it all out, but I could also use Wolfram Alpha, which is a great tool to help me. So what I've done is I've just typed out the original expression, and I'm going to press enter. And it says, I'm assuming the I is the imaginary unit. So basically, it's just asking, is this a variable or not? And it gives me a result of negative 42 plus 82i. So that would be my answer. So on your homework, I want you to feel free to, while you're doing the Khan Academy assignments, to use Wolfram Alpha in order to find the answer, because that's going to get you used to using I, typing it out, and using a resource like Wolfram Alpha or a calculator. Alright, this next one is the trickiest one. I want you to notice that there are two parentheses again. We're still not multiplying because there's a negative sign in between them. So that means we're going to take the first part and subtract everything in the second part. So what that means is you have to distribute that negative. So this is the part that trips people up. We're going to drop the parentheses from the first part. But then we need to make sure that we distribute that negative to both 6, so minus 6. And we're also going to subtract a negative 10i. So that's going to be subtracting a negative 10i, or it's just going to become positive. So adding a 10i. Distributing the negative is the part that trips people up. So once again, we have two real parts and two imaginary parts. We add the real parts together. 3 minus 6 is negative 3. Imaginary parts, 4 plus 10i is going to be plus 14i. You could do this by hand, but you could also put it in the calculator again, or put it on Wolfram Alpha. I minus 6 minus 10i. And it'll give me my answer of negative 3 plus 14i. Okay, we're going to now move on to multiplying. So multiplying complex numbers is a little bit more complicated, but once again, you're going to be able to be using Wolfram Alpha to make it a little bit easier on yourself. And I just want you to remember, before we start, that our I is equal to the square root of negative 1. When we go to multiply, we're going to end up foiling, which means we're going to end up with an I squared term. And something you need to notice is that I squared, think about if I said, okay, I'm going to square I, that means I would square the square root of negative 1. Well, if you're squaring a square, that means the radical is going to cancel out. So it would be like the square root of x squared, it's just x, because the square root and the radical cancel out. So if it cancels out, we're just left with I squared, what's in the radical, negative 1. So this is going to, just keep this in the back of your mind because we're going to do this example really quick. Oops, my bad. So we have 5 plus 2i times, notice there's a multiplication sign here, so we're now multiplying, we're now going to FOIL, times negative 5 minus I. So remember when I talked about Miss Dela Cruz and Miss Alita? And if Miss Dela Cruz made cupcakes and friendship bracelets, and she gives one to Miss Alita but doesn't give one to me, I'm going to be really sad. So we want to make sure that everyone gets everything. So Miss Alita gets a cupcake, and I get a cupcake. Miss Alita gets a friendship bracelet, and I get a friendship bracelet. So we're foiling, or we're making sure every single term gets multiplied by every other term. So 5 times negative 5 is negative 25. 5 times negative I is negative 5i. 2i times negative 5 is negative 10i. And 2i times negative 1 is negative 2i squared. All right, we're going to move on like this I is a variable. So it's not a variable, it's a number, but we also want to combine like terms here. So we have this real part, and then we have these two terms that have an I in them, and then we have one that has an I squared. We're going to get to that in a minute. So I'm going to do negative 25, negative 5i minus 10i is negative 15i, and then I have negative 2i squared. So remember what I did up here. I said if I squared I, that means I'm squaring the square root of negative 1, which is just negative 1. So this I squared, I can replace with a negative 1. So I'm going to do just that. So this I squared is equal to negative 1. Now all of a sudden when I simplify this, it's going to be negative 25 minus 15i plus 2. This is now another real part. So we have to add it to the other real part. So our complex number is going to be negative 25 plus 2, negative 23 minus 15i. So when we have this I squared, it's going to turn into a real number. So this is our simplified form. You can do this on Wolfram Alpha as well. So let's do another example. We'll do it by hand, and then we'll do it on Wolfram Alpha. All right, so we have the quantity 1 minus 2i plus the quantity, times the quantity 4 plus I. So once again, we need to make sure that everybody gets a friendship bracelet, everybody gets cupcakes. So 1 times 4 is 4. 1 times I is I, so plus I. Negative 2i times 4 is negative 8i. Negative 2i times I is negative 2i squared. Once again, I'm going to combine my like terms, which are the I and the negative 8i. 4 minus 7i minus 2i squared. Remember that I squared equals negative 1. So if we're trying to simplify this, we want to get it into complex format. We need to make sure that we don't have an I squared in it. So we're going to replace the I squared with a negative 1, because that's what it's equal to. So we get 4 minus 7i plus 2. We then combine these two like terms. We get 6 minus 7i, and that is the simplified form of it. So once again, you can use Wolfram Alpha. In order to do this, you need to make sure that you're including the parentheses. You don't have to include the multiplication if you don't want to. Remember that if two parentheses don't have an operation in between them, that means that they are multiplication. It's invisible math. So I'm going to write this out, and it will give me my answer of, oh dear, did I write something wrong? Yeah, I wrote something wrong. My bad. Oh, okay, so it'll give you my answer of 6 minus 7i. Please, 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 on homework, use Wolfram Alpha. I want you to get used to using as many resources as you can in order to get the best grade you can. If you have any questions, please contact me through Teams. I'm going to be in training, so I may not be able to get back to you immediately, but I will be able to get back to you eventually. All right. Bye, guys.